Okay, in this video I'm planning on going over GDB, the GNU debugger for C and C++, and it's relevant because it's an extremely powerful tool to debug programs that, while they compile correctly, work very incorrectly, and not quite what you think. GDB is very intimidating to beginning users, so I'm hoping I can quell a little bit of that intimidation. And it's also available for a lot of other programming languages, for Python, PDB, for Java, GDB, or JDB, I'm sorry, JDB for Java, Java Debugger, although JDB does have a few interesting commands different than GDB. So in order to do this, I've put together a simple program that compiles perfectly fine, but has a few or several logic errors. It's in program.c. I have a makefile here. If I go into it, I've got a C compiler of, oops. Wow. There. C compiler of GCC. C flags of G of -G GDB. The -G is to say I want to compile this with debugging flags. So include the source code along with and we'll pack the source code into the executable. And then GDB means I want to include some GDB specific debug flags. It makes GDB work a bit easier. I've got my compile target, which uses CC and C flags, names the program sort, compiles it. I've got a run target to run it, and I've got a debug target to go ahead and launch the debugger, which I'll be using throughout the rest of the time. To launch the debugger, use GDB, and then the command you would use to run your program on the command. You can do that on the command line or from within a makefile. And if I go ahead and glance into program.c, you can see it's the design is the optimal bubble sort, and also have a print array, and it just lays out a 7 long array, prints it, open or does its sort, then prints it again, and goes ahead and returns 0. Now everything is laid out in a way that it would appear to be right, but isn't quite. And it has nothing to do with whether it compiles or not. If I run make, it compiles perfectly fine. Even if you don't trust make, gcc program.c still compiles fine. If I list right now, I have 2 executables made 2 different ways. I'm going to get rid of a.out. So now I'm actually also going to go ahead and get rid of sort and show that. So I'm going to make and run. And let's see what the program does. Okay, it prints out what looks to be our array, and then just holds in some kind of infinite loop. Okay. Something seems to be going wrong. And I could certainly sit there and stare for a while at the program and see if I can find what it is. And you actually do have to start there. If I read through it, I set the size, I set I create the array, I print the array, which if I go down to printing it, it does have a loop, however, I know that that loop ends. So that's not the problem. I know that loop ends. That loop runs fine. And however, if I go here, however, then after I print the array, because I saw the array print, I know it ends. It goes into optimal bubble sort. Here it goes and asks, or goes and I'll just expand it a bit. I've got a variable to track if there was a swap or not on the last iteration. I initialize it to 1, so the loop will actually start. And I run while the value swapped is equal to 1. Value swapped is equal to I reset value swapped. That way it's at 0, and then if I swap anything, I change it to 1. That's the basic idea. And this makes it so if I don't swap anything, I don't have to run through the entire list all those times. It makes it less of a pure n squared algorithm. It's still O to the n, or O of n squared, for those of you who are familiar with big O notation, but it's slightly better. And it's actually really easy to write. So whenever you're writing bubble sort for example, merge sort or quick sort, I'd recommend using this more optimal version. Then I go through and check to see if there needs to be a swap, and then I swap things. And if I need to swap, I label it as having swapped, and it comes back and repeats the loop. If not, it exits. However, print array doesn't run again. So I can have a decent guess that optimal bubble sort is where I have a problem. Okay, that's fine. Line 18. Got it. So now that I have an idea of what I'm looking for, and you need an idea of what you're looking for to use a debugger tool, I now can run my program again. I'm going to use make debug. Can I clear? Nope. Okay, fine. So I'm going to be using a GDB style that I personally prefer. However, I will show a style that a lot of other people prefer more, for a while at least, especially while they're learning, because to them it looks nicer. And actually, I'll show that first, because I probably won't come back to it. I'm not a fan of it personally. GDB-TUI text user interface is what that stands for, and then / sort is my executable. There we go. So what this does is it makes it so it actually shows the source code up here and shows line numbers, and will actually let you see where you're at, compared to normal GDB where you have to run a command to see where you're at. And a lot of people find this to be preferable. I'm not a huge fan of it personally, but to each his own. I will set just to show an example of it running, I'll set a breakpoint for program.c, and I'll go over this a little bit more in a second. I think this works. Yep, there we go. Run, breakpoint set. So now I'm currently on line 7, about to run line 7. And I can move on and continue and follow it. But for the moment, I'm gonna quit and use the style I'm more comfortable with. And if you guys prefer the TUI, feel free to use it. So I just got all this. This is all just license information. The biggest thing I care about is it successfully read my symbols, all my debugging symbols, so it can see the source code. And if I use L for list, I can see where I'm currently at in the source code. It's going to start at int main, and that's put at the middle of that line, and it prints 10 lines total. So approximately 4 or 5 lines before and 4 or 5 lines after. So I already identified that I'm fairly certain the optimal bubble sort has something wrong with it, so I'm going to set a breakpoint for program.c. Now, you can do, if it's a single file, you can just do a single line number, or you can do program.c:18 if it's a multiple file program and you just want to refer to the line number, or if you just want to refer to a function, you can also do that. Optimal and tab completion works as well. If there's if you have multiple overloaded functions, you will have to provide the argument types in order to tell GDB which function you want. In this case, it's just named one name, or I just have one optimal bubble sort, so I'll set a breakpoint there. B stands for breaking, or B standing for breakpoint. To start running my program, I'm going to use R. There we go. And I hit breakpoint 1. So if I hit L, I'm currently at breakpoint 1, and you can use a very useful command, info locals, and this will show you information on all your local variables that are in this, that are being declared. So here you notice when it labeled my function call, it provided me the actual parameters and their names and their values. And here it showed me that I was about to execute line 21. I listed everything out, and then I did infos locals, where value swapped is equal to 4 million and some change. And I'm about to execute a line that sets it to 1. If I want to execute that line, there's two ways to do it. One is the one that people are going to do, the one that I spend the most time doing, which is N, short for next. So I'm going to do N. The one that you'll sometimes want to do, N will step over what you're doing, still executes it, but steps over it. So if you're calling a function, that's especially useful, because it will step over and skip that function and won't go into it. If you do step, it will step into that function. But now I'm going to go ahead and execute while swapped equals 1. While swapped is equal to 1. And then it's going to try and execute value swapped equals 1. For I equals 0, I is less than or equal to size, I plus plus. It sees it needs to make a swap. At this point, it's probably going to be useful for you to see this one. Well, it's about to test if it needs a swap. When you're going and running this, if you're curious about a particular variable, you can always print with P space. In this case, P values swapped. So what I'm going to go ahead and print the value of, it's 0. And also print the value of ARR I. Array at I is 9. ARR I plus 1 is the command is undefined. Print, it's 0. So 9 is greater than 0. So it's going to evaluate that condition to true, that it should, in fact, swap. Next. Okay, so it goes into it. That all works fine and dandy. And value swapped equals 1. So now what I'm going to do is actually a somewhat clever little trick that I use, and that's set a watch point. Values swapped. It means I happen to know a certain fact. Okay, should have been W. Is it watch? There we go. That's fine. Okay, a hardware watch point on values swapped. And what that will do is it will show, or it will watch value is swapped, and if its value changes, it will then stop program execution. It'll just stop right there and let you go and start executing commands to inspect it. And I'm doing that because list 20. I think I can tell it how much to list. Okay, close enough. I listed it centered around 20 on accident here. Apparently that's what the first parameter of list does. So, but it still gave me what I want. I know this while loop is driven by value swapped, and this thing goes from 0 to where it's less than or equal to size, so that should work fine, I'm sure. Say, I'm confident in that for loop ending, so I'm going to keep an eye on when value swapped changes. So in order to continue execution, after you get broken out of execution by a breakpoint and you're done running your commands, you use C for continue. Okay, I've hit something. So hardware watch point 2, value swapped went from 1 to 0. So I reset value swapped, and it is now going to go ahead and try to it's now going to go ahead and rerun the loop. I continue from 0 to 1. So that would recognize the swap 1 to 0, recognize the swap 1 to 0, recognize the swap 1 to 0, recognize the swap, reset, recognize the swap, reset, recognize the swap, reset, recognize the swap. There are slightly more efficient ways to use GDB, but you can get a lot of powerful stuff with just basic knowledge, just simple knowledge. Here I'm just watching the bottom and seeing how it changes. Old value was 1, now 0, that means it's reset. When it changes from 0 to 1, that means it has swapped. And this is just from me knowing the program that I wrote. From 0 to 1, 1 to 0, 0 to 1, 1 to 0. And this just keeps going. And I certainly seem to be noticing this continues. And in fact, I've noticed something interesting. To 0, 0 to 1. Yeah, I seem to have noticed something interesting while looking at the output. And I'm sure a couple people watching this, looking closely, noticed it as well. Last time I had to debug this, it honestly took me and a couple other teachers' assistants a couple hours to find this while I was working on a student's program and trying to help them find a bug. And what I noticed is when it changes from 0 to 1, when it shows it as having recognized a swap, its next command is line 24. Then, when it resets, its next command is line 28. However, in the code, the next command of line 24 is here, and the only thing preceding it is this while loop condition. And then the command here goes into here. Well, once this executes, the next command that GDB is acknowledging is line 28. The declaration event I was optimized out. And so I get, was optimized out by the compiler. C still needs it in certain versions, but like the version I'm actually compiling with. But you have the same thing with, but that's besides the point. So this is getting executed, and what you notice in here is values swapped gets the value of 1. I forgot a second equal sign. Okay, so this should work. Quit. I've now found what I believe to be, or I've found my bug that's causing my infinite loop. Because in C, whenever you do assignment in a Boolean condition, it will return true if the assignment succeeds. It will evaluate to false if the assignment fails. So that creates an infinite while loop. Always something to watch out for, and something I programmed in knowing it's a very common mistake. So go into program.c and go over, and now that we've learned how to use GDB if we find any other bugs in here, we should be able to find them quickly. So make run. Let's see if this is right. Whoa. That doesn't look right. That doesn't look right at all. Okay. So it's definitely running all of my code. And it looks, or for some reason, well, this first bit of the array was sorted right, although the 0 came from somewhere, is the original array didn't have a 0. It didn't have more than 1 0. It only had 1 0. So a 0 appeared, and it did this giant thing. So somehow its size got bigger. Okay, let's see what we can do. I'm gonna go back into GDB, because I actually have, have an idea of what I want to look for, or what I want to see what's happening. Because for some reason the size between those two different arrays that were printed are different, and as you almost undoubtedly know, whenever you're printing an array, you're passing an array around, you have to pass the size along with it. So it looks like that size variable got changed somehow. So, okay. Set a breakpoint for program.c main. And that. Run. So I get to here. I set size equal to 7. Next, I create that array. And then I go into print array size, which I will go ahead and step into. And I will see here that size is 7. And the array is that. Okay. Now I'll step. That should. Oh, that set a breakpoint. Dang it. Info. B. Breakpoint. Delete. Breakpoint 2. And now if I do an info B. Okay. This isn't what I want. Okay. There is a way to step out of this, however, I cannot seem to remember it off the top of my head. So I'll just go ahead and continue real quick. It's a small array, so it'll be easy to get out. There we go. I'm out. And you notice while I'm in GDB, all this normal output works. All the normal input also works. So now I have my optimal bubble sort. I'm going to step over that with next. And now I have print array the second time. I'm going to step into that, and size is suddenly 20. Well, that's not right. So I'm going to continue, let the program end, and now I'm going to delete breakpoints 1, set a breakpoint 4, program.c, optimal bubble sort. Thought we were done with this, but we obviously are not. So now I'm here, my size is 7. I'm going to watch size and see what happens. It'll be fun. So let's see what comes along. Hardware watch point 4 size. Okay. So continue. So that's the block at which the expression is valid. So that size never changed. And if I info locals, size is 20. Okay. Oh, but this nicely sorted array has lost its value of 100, but has gained a value of 0. And has lost has kept the value of 7. Okay. And has lost a value of 20. Well, that's confusing. Let's see how many elements are here. 1, 2, 3, 4, 5, 6, 7, 8. That's not right. It shouldn't be 8. The size is 7. Okay, so let's do that. And now let's go ahead and break point program.c print array. And run print array. Okay. Next. Next. Always be careful with always be careful to use next when you're about to run C or C++ libraries. It will not be fun trying to get out of them. So, I0, watch, I. Continue. And I'm just using a watch point so I can see what values I takes on. And what we're expecting it to take on, since size is 7, we're expecting it to take on 0 to 6, right? Because it's an array. It starts at 0, so 0, 1, 1, 2, 3, 4, 5, 6, 7. Sorry, 6. 1, 2, 3, 4, 5, 6, 7. There's 7 numbers. So it should take on 0 through 6. Let's see if that happens. New value 2, 3, 4, 5, 6, 7, 8. Well, okay. 8 is when it exited. 8 is when it got too big. Oh. I put less than or equal to size. Okay. That's a mistake a lot of people make. So let's quit vim program.c and let's look. I'm also going to look as I do my wow, I made it in a lot of places. Okay. So, there. Less than size, less than size. And actually, I just showed that I wasn't watching my indexes very carefully. So let's make sure that this for loop right here isn't going out of index. I equals 0, I is less than size, plus plus I. If array I is greater than array I plus 1. Oh. That means that even when it's just less than size, so even when it's just 6, the next index will be 7. That must be where that extra 0 came from. Okay, so I guess we will do size minus 1. I think I remember seeing something about that when I was doing research on this algorithm. Okay, make run. 903 20 16 5 100 035 9 16 20 100. Wow, everything worked. And just to be safe, I'm actually gonna check that, even though there wasn't any risk of me having memory leaks. I just wanted to be sure, because memory leaks are always a possibility, and Valgrind is a really nice command line tool to look for them. So there's a optimized bubble sort program that works perfectly fine and is perfectly functioning. At the start, it compiled perfectly fine. However, as we just saw, there were a few very subtle errors in my logic when I wrote it. Now, naturally, I know this algorithm and I know how to write it off the top of my head. However, I also, with my 3 years of experience, well, this is my 3rd semester, sorry, not year, semester. This is my 3rd semester teaching as a teacher's assistant for IUPUI's CS class that teaches C, C++, and Java. I know some of the common mistakes that students make every semester when it comes to these kinds of assignments. And so I went ahead and included a couple of them and noticed that I was able to debug them with GDB without having to look through the code line by line. And this was actually a fairly small program. Now GDB is actually extremely capable of doing large programs. And other debuggers, visual debuggers that people might tend to prefer, are going to often use GDB. The one I use most often that's a visual debugger is Visual Studio Code, which for C and C++ uses GDB. At least on my Linux machine. I don't do any development on Windows. Just not something I'm a fan of. So, with the very little browsing through my code line by line, I was more watching how certain values were changing while it was running. I wasn't guessing what the values were. I knew the truth of what the values were. I could see it in the code. Each time I went in with something that I was expecting to happen, and I was seeing if it did happen or if it didn't happen. And then once I found it, I could fix it easily. Any bug can be fixed once it's found. The problem is finding it, and that's what GDB is helpful for. I hope I might have been able to turn your view a little bit and made it a little bit more likely for you to go ahead and use GDB. If you're still feeling stubborn on it, fine. However, I find this to be a lot more elegant than print statements and just having a lot of print statements. I find that to be a somewhat unrewarding solution to a problem, and finding a solution to this problem.